a dummy variable. If you replace t with, say, f of u du, this integral does not change because this represents this integral itself. If I draw the function f of t against t, it might look like something. And here's a, here's x, and the function is representing the signed area over here. So if I just change this t to u, that value of area is not going to change. That's why we call t a dummy variable. So the function has to be in terms of x. And that should be clear because you're differentiating with respect to x. So the function's argument should be x. And it's actually here, which makes sense because if, again, I draw the same graph, a is a constant, and say if x is 1, then this would be the output of the function. But if I change x, I get different values. So it does make sense that x is the variable of this function. Now you understand that this whole thing is actually a function in terms of x. We're saying that the derivative of that function with respect to x is equal to the function you integrated. So what the first part is actually saying is, if you have a function, if you integrate it, then differentiate it, you get the function back. That suggests that differentiation and integration have somewhat of an inverse relationship because differentiating cancels out the effect of integrating. If you think of the first part like that, that's a pretty good start.